When a 200 amp main disconnect is located at a remote pedestal, that pedestal is designated as the main electrical panel. Consequently, the electrical panel at the house becomes a subpanel. Understanding this distinction is crucial for proper grounding and safety. Considering a 4-wire system which incorporates a dedicated equipment grounding conductor or EG, an electrode at the house is typically not required. The EGC serves as an adequate grounding pathway for fault currents and lightning surges. In contrast, if a 3-wire system were utilized, an electrode at the house would be necessary. In a 3-wire configuration, the neutral conductor also functions as the EGC, mandating an additional grounding path to enhance safety. Regarding the isolation of the EGC and neutral within the subpanel at the house using a 4-wire system, it is imperative that these conductors remain separate at the subpanel. This separation can be achieved through the implementation of an isolation bar or insulated bushings. Furthermore, the subpanel at the house must be appropriately bonded to the EGC and the grounding electrode system located at the remote pedestal. This bonding ensures a secure and reliable grounding connection. Now let us discuss the technical details in depth. Firstly, the main panel, located at the pedestal, is the primary point of service for the electrical system. It is the location where the utility power enters the premises. This panel contains the main disconnect, which is used to energize the entire electrical system. Secondly, the subpanel, located at the house, is fed from the main panel. It is used to distribute power to the various circuits within the house. Because the subpanel is fed from the main panel, it is not considered the primary point of service. For the 4-wire system, it comprises 2 hot wires, 1 neutral wire, and 1 equipment grounding conductor or EGC. The EGC provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker and clear the fault. Because the EGC is a dedicated grounding conductor, it is not necessary to install an electrode at the house. The EGC is typically connected to a grounding electrode system at the main panel, which provides a path for fault current to ground. Now let us look at the 3-wire system. It consists of 2 hot wires and 1 neutral wire. In this system, the neutral wire serves as both the neutral conductor and the equipment grounding conductor. This means that the neutral wire must be sized large enough to carry both the neutral current and the fault current. Because the neutral wire also serves as the EGC, it is necessary to install an electrode at the house. The electrode provides a path for fault current to ground in the event that the neutral wire becomes disconnected. The isolation of the EGC and neutral at the subpanel is a critical safety requirement. If the EGC and neutral are not isolated, then fault current can flow through the neutral wire. This can cause the neutral wire to become energized, which can create a shock hazard. To isolate the EGC and neutral, it is necessary to use an isolation bar or insulated bushings. An isolation bar is a metal bar that is used to separate the EGC and neutral wires. Insulated bushings are used to insulate the EGC and neutral wires from the metal enclosure of the subpanel. The bonding of the subpanel to the EGC and the grounding electrode system at the remote pedestal is also a critical safety requirement. Bonding is the process of connecting all of the metal parts of the electrical system together. This includes the metal enclosure of the subpanel, the metal conduit, and the metal grounding electrode system. Bonding helps to create a low impedance path for fault current to return to the source. This helps to trip the circuit breaker and clear the fault. The National Electrical Code or NEC provides detailed requirements for grounding and bonding electrical systems. It is important to consult the NEC to ensure that your electrical system is properly grounded and bonded. Specific sections in the NEC relevant to grounding and bonding include Article 250, which covers grounding and bonding in general, and Article 408, which covers switchboards and panel boards. The NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors for grounding raceway and equipment. Moreover, NEC Section 310.15 provides guidance on ampacity of conductors. Grounding electrode conductor sizing is covered in NEC Table 250.66. The purpose of grounding is to limit voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines and to stabilize the voltage to earth during normal operation. Grounding also facilitates the operation of overcurrent protective devices in case of a ground fault. Bonding, on the other hand, ensures electrical continuity and the capacity to conduct safely any fault current likely to be imposed on it. The equipment grounding conductor (EG) is a crucial part of the grounding system. It provides a low impedance path for fault current to return to the source, allowing the overcurrent protective device, such as a circuit breaker or fuse, to quickly clear the fault. This minimizes the risk of electrical shock and fire. When installing a subpanel, it's important to follow the NEC guidelines for separating the neutral and ground. The neutral bar in a subpanel should not be bonded to the panel enclosure. This ensures that the neutral current flows only through the neutral conductor and not through the grounding system. The grounding bar, on the other hand, should be bonded to the panel enclosure and connected to the equipment grounding conductor. Remember that the location of the main disconnect determines whether the house panel is considered a subpanel. If the main disconnect is at the pedestal, the house panel is a subpanel. In this configuration, the grounding and bonding requirements are different than if the house panel were the main panel. For example, you must isolate the neutral and ground at the subpanel. In a 3-wire system, the neutral conductor is used as the equipment grounding conductor, which is not allowed for subpanels in separately derived systems or when extending circuits from the main panel to a detached building. In such cases, a separate equipment grounding conductor is required. The size of the grounding electrode conductor is based on the size of the service entrance conductors. Refer to NEC Table 250.66 to determine the appropriate size. The grounding electrode conductor connects the grounding electrode to the equipment grounding conductor, the neutral conductor, or both, at the service equipment or separately derived system. The grounding electrode system typically consists of a ground rod, a ground ring, or a metal water pipe. The NEC specifies the requirements for these grounding electrodes. The proper installation of grounding and bonding systems is critical for electrical safety. It is important to consult the NEC and follow the manufacturer's instructions when installing these systems. It is also recommended to have a qualified electrician perform the installation to ensure that it is done correctly. When dealing with electrical systems, safety should always be the top priority. Improper grounding and bonding can lead to electrical shock, fire, and other hazards. Always follow the NEC guidelines and consult with a qualified electrician to ensure that your electrical system is safe. The information here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before working on electrical systems. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock and other hazards. Ensure that all electrical work is performed by a qualified electrician who is familiar with the NEC and local electrical codes. The proper grounding and bonding of electrical systems is essential for the safety of people and property. Remember, the NEC is updated regularly, so it's important to stay current with the latest requirements. You can obtain copies of the NEC from the National Fire Protection Association or NFPA. Many jurisdictions also have their own electrical codes that are based on the NEC. These local codes may have additional requirements or modifications to the NEC. Be sure to comply with both the NEC and your local electrical codes. The inspection of electrical installations is important to verify compliance with safety standards. The grounding system is the most important component of the electrical system. The grounding electrode system must be in place to protect the panel from surges and supply the path to ground for electrical faults. Electrical codes are updated every 3 years, so make sure you are using the most current version of the NEC for your location. To summarize, always ensure proper grounding and bonding, use the appropriate wiring methods, separate the neutral and grounding subpanels, and consult with a qualified electrician for any electrical work. Proper grounding and bonding ensures a safe and reliable electrical system. Remember to always prioritize safety when working with electricity and consult with a qualified electrician if you have any questions or concerns. Ensuring that the pedestal panel is considered the main panel and the house panel is a subpanel has implications for overcurrent protection and coordination. The overcurrent protective devices must be selected and coordinated to ensure that a fault on a branch circuit will be cleared by the branch circuit breaker and not by the main breaker. This helps to prevent a complete loss of power to the house. Also, it's important to consider voltage drop when designing the electrical system. Voltage drop is the decrease in voltage that occurs as electricity travels through a conductor. Excessive voltage drop can cause lights to dim, motors to run slowly, and other electrical equipment to malfunction. The NEC provides guidelines for minimizing voltage drop in branch circuits and feeders. Moreover, surge protection is another important consideration for electrical systems. Surges are sudden increases in voltage that can damage or destroy electronic equipment. Surge protective devices or SPD can be installed to protect electrical equipment from surges. The NEC requires SPD to be installed in certain locations, such as at the service entrance and at subpanels. When running the underground feeder from the pedestal to the house, it is important to use the correct type of cable. Underground feeder or UF cable is a type of cable that is designed for direct burial in the ground. UF cable is moisture resistant and can withstand the stresses of being buried underground. Conduit can also be used to protect underground feeders. Conduit provides physical protection for the conductors and can also help to prevent moisture from entering the cable. The NEC provides requirements for the type of conduit that can be used for underground feeders. Also, be sure to use the correct size of conductor for the underground feeder. The size of the conductor is based on the ampacity of the circuit and the length of the run. The NEC provides tables that can be used to determine the correct size of conductor. When making connections in electrical panels, be sure to use the correct type of connectors. Connectors must be properly sized for the conductors and must be listed for the application. The NEC provides requirements for the type of connectors that can be used in electrical panels. Remember that working with electricity can be dangerous. Always take the necessary precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment or PPE, such as insulated gloves and safety glasses. To energize the circuit before working on it and verify that it is de-energized with the voltage tester. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. In addition to the technical aspects of grounding and bonding, it is also important to consider the aesthetic aspects of the installation. Be sure to install the grounding and bonding equipment in a neat and workmanlike manner. Use appropriate hardware and fasteners and follow the manufacturer's instructions. A well-installed grounding and bonding system will not only be safe and reliable but also look professional. Ensuring that the electrical system is properly grounded and bonded is a shared responsibility. Homeowners, contractors, and electricians all have a role to play in ensuring that the electrical system is safe and compliant with the NEC and local electrical codes. By working together, we can create a safe and reliable electrical environment for everyone. Finally, remember that electrical codes and standards are constantly evolving. It is important to stay up to date on the latest requirements and best practices. Attend training courses, read industry publications, and consult with qualified professionals to stay informed and ensure that your electrical work is always safe and compliant. The goal of electrical safety is to protect people and property from the hazards of electricity. By following the NEC and local electrical codes, using appropriate materials and equipment, and working in a safe and professional manner, we can all contribute to a safer electrical environment. This is especially critical with increasing complexity of modern electrical systems. Understanding grounding and bonding principles, especially in main panel and subpanel configurations, is essential for anyone involved in electrical work. It ensures safety, prevents damage, and complies with regulations.